Good day. I'm Dr. Dulay and I'm here to present the development of an Android-based graphical user interface for a low-cost ship automatic identification system. You'll also see on the screen my co-authors. What is an AIS? It is a tracking system that is required to be installed in ships to avoid collisions. It has a chart plotter, usually, that will show the different information such as call sign, locations, the maritime mobile service identity, and the other information. Now, the SOLAS and the IMO, or in the International Maritime Organization, have declared that all those ships or vessels that operate at 500 tons and all passenger vessels should be installed with an AIS. Now, there are two classes of AIS, Class A and Class B. Class A is usually used in bigger ships, while Class B is used for smaller ships. Now, just to give you an idea of how much commercial AIS is, the cheapest is around 20,000, and then we can have actually more than 58,000. These are the only uh, equipment that I found in, typical Shopee and Lazada, but they can go as high as 100,000 pesos. Now, the aim of this research is actually to provide a low uh, cost version of the AAS for use by the fishing vessels or smaller vessels. Okay, so that's the idea. Now, in order to do that, uh, we just needed an antenna. If you're going to look at the screen, it's only around $75. And then, of course, the receiver, which is around $95, and the mobile app. Because the cell phone is now commonly used even by fishermen, so why don't we make use of that? No? So we can eliminate, the other equipment or parts that make up the AAS. So we just focus on this one here because these two here can already collect the data, and then we just interpret it and then plot it here and display on our mobile application GUI. So the initial uh, desire is actually to have this design here. That is, we have the antenna and then we have the receiver. It will now be sent to the phone via Bluetooth. No, so if you're going to use the expense, if you were going to plug in the expense earlier, that's less than 10,000 pesos, much less than the commercial available AIS, right? However, because of pandemic, we only able to do this. Okay, so as you can see, that you still have the phone there, of course. Now we were able to develop the GUI, but we were not able to do the real-time thing. Now, the good thing about it is that during the initial collection of data, now we started with this actually, with this one here, where we sent the information that we received, the messages, we call that messages, no? That we received from the antenna. It's being sent to the laptop, okay? Because initially we wanted to decode because the information is, of course, in a form that is not readily convertible to a useful information in the mobile phone. So there's a need to decode that first. Okay. However, when we were already doing, so supposedly we were going to get rid of this already, no? But after collection of the initial data, the pandemic already started, and we were not able to go back to the university. In fact, up to today. And it was unfortunate that the antenna and the receiver were left in the premises of the campus. Thus, we were limited to the initial data that we have collected. Fortunately, we have collected a lot now, so it helped us in developing the mobile app in determining whether the data that we have presented here is correct or not. Okay, so this is the raw data from the AIS antenna. If you're going to look at it, it's useless information. There is a need to decode this, and fortunately, the putty program in the laptop is the one that decodes it to this format. So we found a paper that shows how to decode this message here. Okay, where the first field here tells us whether it's AIVDM or AIVDO. AIVDM is actually the message coming from other ships, while AIVDO is the message coming from the user's own ship. Okay, and then we have a fragment, number, sequential message, okay, radio channel, and then we have the payload. This is actually the data that contains all the information that we have displayed in the mobile app. Now, how does the ship send information, no, so that they will not collide? There's a specific standard for that. It is using actually TDM, or time division multiplexing. Okay, and the idea is that they will be selecting a certain slot, and they are the only one who can, once they already have selected the slot, they are the only ones who can send in that slot. No? So typical time slot is around 26.6 milliseconds. And once they already have sent the information needed, the other ships will come in. Okay, so that's the idea. Now, this is just a sample of the list of the data that we collected before the campus closed in 2020. So this is the AAS mobile block diagram for the graphical user interface development. Okay, of course we have the login and register block, we have the input selection block, the reference location selection, the file selection, the decoding and data logging, and then the graphical user interface, which contains, of course, the map. This is how it will look like. This is how it looked like, the screen. Now this is for the register, this is for the login, and this one is for the selection, input selection. Okay, so as you can see, for the login here, there's of course some kind of authentication by using a password. Okay, and it uses SQLite for the database. Now for the input selection, we can either choose this one or this one. No? Had we not have the cancellation of classes in March 2020, then we could have continued with this one here. Now, where we're going to get rid of the laptop already, and we just continuously send information from the receiver to the mobile application, because that's the very idea of the low-cost AIS. So this is for the reference location selection. The purpose of that is to, of course, determine the distance now from a certain point to another point. Okay, so we have to set the reference location. It can be from one ship and then to your ship, for example. Now in this presentation here, you can see that it is being pinned on the map. No, at, say for example here in Intramuros, that's the South Harbor there. Okay. And then for the input selection, we do have the files in the mobile phone, okay, that we displayed on the screen. And then we have the decoder and data logger. This one here will show you what is the activity, and usually visualized by a circular progress bar, just like what our normal app would show when it is processing. Okay, and in this data and the decoder logger, we also included the Haversine distance calculation function, because the information coming from the ships do not include the distance. It simply includes its latitude, longitude, and then the MMSI earlier. Okay, so from the latitude and longitude, though, you can already calculate the distance between 2 points. Okay, so the program used Marine API for decoding and data logging. So I'm not showing you anymore the other codes. Okay. Now for the map, this one here shows the map, as you can see. Okay, and we have here the ships being represented by the orange triangles. And we have added a feature where if we're going to press a certain ship, okay, if we wanted to know the information about the certain ship, including the distance relative to the reference location, the marker turns to green. Okay, so that the user will not be confused, no, which particular object it pressed. Because as you can see, you have there the green colored marker, which says that that is the one being chosen, and the information, okay, is displayed. Okay, so the map actually has been modified for clearer viewing. As you can see there, we have here the information once this one is pressed, and it uses Maps SDK now for Android from the Google. Now for the data and results, we have, of course, this one, the map, now where we have not pinned any ship. Okay, so all of them are orange, and then of course this red one here, pin, is the reference location. And then once we press a certain ship, we have this one, and then of course the information window pops out, so and shows the, okay, the latitude, longitude, and the distance, plus of course it's MMSI. Now, one of the constraints of the project is to ensure that the code will fit the Android Go platform, no, which has the following specifications. Okay, fortunately, for the storage, the program is able to fit at 9.3 MB only, which is very much lower than the storage requirement for Android Go. And for the RAM, we have here also 256 MB only, which is less than 1 gig. We have the PSS, okay, which is still within the range. And then the target SDK version, and the startup time is less than 5 seconds. Now for the distance reference function, we have here the, of course, location. We chose 10 ships, and we have compared it with an online calculator, distance calculator. And out of the 10 ships, only one has some slight difference, no, with our application. And this is caused by rounding error. For the data logging, we also have shown that the data is deleted after the period that we set, no, for it to be deleted, which is 7 days. But of course, it can be changed in the code. For the conclusion, this project was able to successfully design a low-cost mobile AIS with the following features. It has a user authentication using password, and then it included also data logging, so that we can browse again the information before the period to which it will be automatically deleted. And there's also a distance calculation, plus of course the GUI map, so that we can easily visualize the position as well as the relative distance of the different ships. Now the decoding was also successfully done using the Java Marine API, and as shown earlier, the code was able to fit the Android Go platform. For the recommendation, this is what we could have done, no? Had the pandemic not started. That is to really show real-time activity. Okay. By the way, all of those data that we collected are real data. Now they really come from ships, because we have the antenna there, and it can receive, no, the data from ships nearby. In fact, ships from Manila Bay and the nearby Cavite area. So that's how good the antenna is. Okay, and we also recommend that the prospective proponents will integrate an interpolation function in case of disconnection. So that's all. Thank you very much and have a good day.